Alright guys, we're going to be working on page 137 in our math book. Dakota had a kite with 25 and 6/12 feet of string. The kite got stuck in a tree. She lost 4 and 3/12 feet of string trying to free it. How much string does she still have? She lost it, so that tells me we're going to subtract. So she started with 25 and 6/12 feet of string, and she lost 4 feet and 3/12 feet of string. How much does she still have left? And I'm going to put F for feet. So this is a subtraction problem. The first thing I want to do is make sure I have a common denominator. My denominators are 12, so we're good to go. When we subtract, we like to line everything up by place value. This one doesn't even look like there's going to be regrouping. So I can subtract my fractions since the denominators are the same. Subtract my numerators. 6 minus 3 is 3. My denominator needs to stay the same. Now I have 25 minus 4. I'm left with 21 and 3/12 of a foot. Complete the name collection box for 3 and 900. So I'm going to go ahead. First I'm going to write that in word form. So up in front of the decimal I have the number 3. And for the decimal I'm going to write that word and. Then I have my next number, which is 9. And the smallest value of that is hundredths, 9 hundredths. Now I want you to think of other ways you can solve this here. You can think about expanded form, going to the back of our book, and thinking of all the different options here. We look down here. We have a couple different options that we can use to write in expanded form. One where the decimals are fractions, and one where the decimals are hundreds. Please try both here in this box. So I'm going to take each digit and multiply it by its value. So that's 3 times its value, 1, plus 9 times its value. 9 is 2 places behind the decimal, so that's the hundredths place. So 9 times 0, 1 for 100. We also have 3 times 1. And then I'm going to write this as a fraction, 1 over 100. So that 9 is as if I had 9 pieces out of 100. So it's a very small piece. All right, now I'm going to write this number in expanded form. And we want to make sure that we're using multiplication and addition and that we're not just writing it with addition. So I have a 1 in the tens place, so it's 1 times 10. My next digits is 7. That 7 is in the ones place, so 7 times 1. And notice I'm adding each of these as I go. The 8 is in the tenths place, so I'm going to do 8 times 1 tenth. You could, instead of writing 1/10 as a fraction, you could write it as a decimal. It would look like this. Plus our hundredths place, well, that's a 0, so I can leave it blank. Now 3. 3 is in the thousandths place, so 3 times, and I got to stay consistent, so I need to keep it as a fraction, 1 over 1,000. So that 3 is extra small. That's like taking one thing and dividing it by 1,000 and only having 3 of those pieces. To write that as a decimal, you would have written decimal 001. Write the division number story that would give an answer of 3 and 5 tenths. So it's like you're having 3 things and you're sharing it with 5 people. So 5 friends share. What are they going to share? Are they going to share bags of chips? What are they going to share? They're going to share 3 what? 5 friends share 3. You need to fill in that blank. 3 chips, 3 pieces of pizza, 3 watermelons, 3 sandwiches. What are they going to share? So 5 friends share 3 blank. How much of blank does each friend get? You need to fill in those blanks. So for example, if I say 5 friends share 3 bags of chips, how much, well in this case I would have to change it up a little bit, but how many bags of chips does each friend get? So you need to make sure that this all agrees. Or how much of a whole pizza does each friend get? So you really need to think about what is your stuff that you're putting here. That's your item. Whatever that is needs to go here, but it needs to agree. So it might not be how much, it might be how many. I don't know, it depends on how you write it. So when you write this in, make sure you say it to yourself and make sure it makes sense. A clerk stacked these boxes to create a store display. Each box is 1 unit cube. Find the volume of the store display. So I would like to segment this here. There's a couple ways I can do it. I'm going to take this section here, and I'm going to label this section A. Then I have this whole section here. I'm going to label this section B. And I have this section here. I'm going to label it section C. So I sectioned it 3 ways. You might section it more or less ways. It does not have to be the same as mine, but it does need to have the same volume. So section A is going to be 1, 2, 3, 4, 5, 6 by 2 by 1. And notice I left 1 for the end because it's just easy to do in my head. B, now I'm going to go 1, 2, 3, 4, 5, 6. So all of these are going to be the same height and the same width. 1, 2, 3, 4, 5. And then my final one is 2. And we know they're all the same height and they're all the same width. And then when you have these, you have to find the individual volumes, then add together. 6 times 2 times 1 is 12. 6 times 5 times 1 is 30. 6 times 2 times 1 is 12. Now you're going to add them up. 2, and make sure you line up your place files. 2 plus 0 plus 2 is 4. 1 plus 3 plus 1 is 5. So my total units, no matter which way you solve it, is going to be 54 units cubed. Write a division problem from which your estimate might be. So here, you would want to have a number that is close to 7,000. That means when you're thinking about it, what's easy to do in your head, that would be 7,000. For me, I'm just going to go a little bit over. 7,117, just because I love the number 17. Then I'm going to divide it by a little bit over, under 100. I'm going to go here with a little bit under 100. I'm going to think about this as 81. I wonder what that would be. Everybody might have a different answer than me. You might have set up a different problem, and that's okay. But what I need you to do is make sure you show your work. It's best to use graph paper when you're dividing. But for some reason, I didn't set up any graph paper when I set up to record today. So sorry about that. 81, I got to think about how many times does it go into 7? Well, it can't. And it can't go into 71 either. So how many times does it go into 711? So I really got to think about 8 times what is close to 71? Well, I know 8 times 8 is 64. Is there anything closer? 8 times 9 is 72, so that would be too much. So what's 8 times 7? Maybe that would work. Oops, no. Sorry, that would not work because that's going lower. So 8 times 8 is what it has to be because I know 8 times 9 is going to be too much. So 81 times 8 is 648. So the 8 would go here. I have to regroup quite a few times. And this is where a lot of us get stuck. So 11 minus 8 is 3. 10 minus 4 is 6. I got to bring down the 7. Now 648 is so close to 637, but it's too much. So I'm going to adjust my quotient and go down 1. I'm going to say 81 times 7. 1 times 7 is 7, 56. All right. Now subtract, remembering to regroup. 13 minus 7. So my remainder is 70. And if I were to report that as a fraction, it would be 70 over 81. I'm going to record that in my book. But everyone's answer is going to be different. It just all depends on what equation you chose to do. And I hope many of you chose different equations. I think about this. 87 and 70 over 81 is very close to 70. So I think my answer is reasonable.